Hello everyone, welcome to Geo-Industry Talks 2021. I'm the founder of Surveillance Engineering. We are dealing with 3D photorealistic data production using reality capture techniques. Today, I have three special guests, Mr. Alex Harvey from PreVR, Mr. Azat Balabanian from Realities.io, and Mr. Stefan Oldenberger from Schneider Digital. We are going to talk about what is the real for next. When you enter the 3D digital world with your phone while sitting on your sofa, we can actually examine the product as if we had it on our hands. We can visit places as if we were there, and we can shop with virtual experiences. These experiences in the virtual world are spreading rapidly because of the pandemic process and the developing of the technology. We experience this situation where the reception of reality and virtuality is lost while navigating digital data which is very close to reality. So what awaits us in this environment where reality and virtuality are intertwined? It's really exciting topic, and let's go ahead. I would like to start to say welcome to my guests. Welcome all. First of all, I would like to start with Alex. Would you give brief information about yourself, please, Alex?
Thanks, Mehmet. Really good to be here. And yeah, I'm the CEO and creative director at River, and we make virtual reality training experiences for the blue light services mainly all over the world. But we definitely specialize in doing photogrammetry to virtual reality and photogrammetry to augmented reality as well. So yeah, scanning lots of things and just loving it at the moment because the momentum is just with everything virtual at the moment. So it's really moving, things are moving fast.
Thank you. Azat, could you please explain briefly information about yourself?
Sure. Yeah, I'm Azat Balabanian, and I'm the director of photogrammetry at a startup in Berlin called Realities.io. And like Alex and River, we are also a photogrammetry company specifically focused on virtual reality and augmented reality. We've been around for about five or 6 years now. And our latest work is actually taking photogrammetry models and creating 3D puzzles with them in a game called Puzzling Places, which recently launched for the Oculus Quest. And so we come from a much more industry and also archaeology background, so much more enterprise heavy. And that was what we were using photogrammetry for quite a long time. But very recently we pivoted into building a game just based on photogrammetry itself. And so that's where we are now.
Thank you. Stefan, would you give brief information about yourself, please?
Yeah, my name is Stefan Oldenberger. I'm a geologist and photogrammetrist. I've been in the photogrammetry GIS business for the last 30 years. We started with digital photogrammetry in the late 80s, started using LCD shutter glasses for stereo, and these days I'm working for Schneider Digital in Germany, which is a specialized hardware manufacturer for 3D stereoscopic desktop systems and large format stereoscopic VR walls. So we have complete VR interactivity on the desktop without being immersive, and we have the VR interactivity on large format 12 square meter power walls with 6K resolution, which of course cater to a very large audience.
Thank you very much. Alex, could you tell us about your solutions a little bit more deeply?
Okay.
Yeah, definitely. We started off making fire investigation training for the firefighters, and it was really important for us in that world to make it as real as possible. And the background for me was the games industry. I was at Codemasters making racing games, so realism was always the thing that we drive for and strive for there. So I was a little bit disappointed when virtual reality came out, and it all was a little bit cartoony until I tried some Realities stuff. Realities.io. I'm so pleased to be on the. It was literally the first sort of thing that I tried in VR, like the old school hall that you'd have a look around inside VR. And for me, that was the starting point. I was like, I want this, but I want interactivity. I want to be able to pick things up and move things around, and then I think we were there. It was like a moment. That was definitely like you could see the power of it if we could have it all photorealistic. So we scanned a load of burnt out fire scenes for the firefighters, and we created a product that's been selling for the last 2 or 3 years now. It's room scale product, fire investigation, and you go into 8 different scenarios and find the cause of the fire using a torch, using every item has been scanned from every angle so we can pick it up. But now we've moved on to making crime scene investigation. So we're doing that for standalone Quest rather than having the Vive. But yeah, they're the 2 main products. And the other thing that we've made is Riverlink, which is a 3 degrees of freedom product. Instead of being room scale and walking around, we allow the trainer to put the headset on 15 people at the same time, and you're all inside a 360 video or looking at a 2D video in a cinema, and you're all in there together. So they're like sort of the 3 main products, if you like.
Thank you very much. Azat, could you tell us about your solutions a little bit deeply?
Yeah, so originally the company Realities, as Alex mentioned, was built as a sort of a virtual tourism app for VR. And so that required very, very high resolution scans and also high resolution playback at performance in VR, which is very difficult because VR is very, compute intensive. So we had to sort of build a pipeline, a whole workflow around being able to optimize high resolution photogrammetry scans. And so that was the first product we built as an internal tool. It was an optimization pipeline to take high-res scans and make them run in VR, including all the way down to a mobile Android device, which is what modern-day Oculus devices are. And from that sort of from a happy accident, in fact, this game came out, Puzzling Places, which is we take 3D scans and we cut them into chunks, to pieces, puzzle pieces, and then you just put them back together. A very simple concept, but it's extremely fun to play with. And that certainly came out of, it was certainly a bug turned into a feature moment because it was using our optimization pipeline, which cuts these large scale scans into however many pieces that you need to support occlusion culling and frustum culling in 3D engines. By accident, the pieces were not arranged properly. And so one of the engineers on the team, Shahyar, who suggested maybe we should just send it to a client this way and they will just put it together with their hands. So the idea started there. And
that's addictive, very addictive.
Yeah, Alex actually is in River's company we've been speaking with and also working with in terms of sourcing photogrammetry content to create puzzles with. And so in a future date, we're actually going to be releasing one of the scans that they've done. So that's a potential that there's quite a lot of scans that exist in the world, clearly, like everyone here, but quite a lot of things don't get published as well. They just sometimes sit in our archive, and so making a puzzle with them is a fun opportunity.
Thank you very much. Stefan, could you tell us about your solution, please, a little bit deeply?
Yeah, we're seeing a shift right now from the old LCD shutter glasses, which were cumbersome to wear to view stereo on a single 120 hertz desktop monitor. We're seeing a shift to other systems, and most prominently to dual screen passive stereoscopic systems. Those we are building in different sizes. They go up to 4K. In other words, you have a dual 4K display, which is very sharp, very clear, very bright. You can use them in daylight, so you can have a normal office environment. And instead of the heavy LCD glasses, all you need is essentially the lightweight shutter glasses. The lightweight polarized glasses. And there's a cross-polarization system that works with a 90-degree polarization difference between the left and the right eye to do the channel separation. And as such, it's really a system which is very user-friendly. So I catch myself running off the booth here at Intergeo with the glasses on, and I say, oops, I still have my sunglasses, so to speak. And same likewise, people can work with 3D stereoscopic content, with aerial photography, with 3D city digital twins all day long without getting a headache, without fatigue. And we make it more user-friendly. This is our goal, and we care about the operators and operators that have used LCD shutter glasses. They never go back to them once they've used the dual screen stereoscopic display systems, then it's no way back, because LCD shutters is really old technology, some 35 years old, and what we have now already has a 15-year history. Planar built these systems originally starting in 2005, and we took over in 2016, further developed them, improved the design, did better calibration of the two monitors together. So overall, we built a much better desktop system, which people can use all day long. And I think that's the clue, and that's the big difference against the VR headsets, which you can wear for a certain period of time. It's fully immersive. If you actually work in a stereoscopic environment, you can do that maybe for half an hour. But those desktop systems allow you really to work productively the whole day long. And I think this is where we are, and this is the way forward also for stereoscopic visualization.
Thank you very much. Alex, you are using laser scanning and photogrammetry methods while preparing photorealistic virtual scene. When we put on the headset, we are in the digital photorealistic copy of a real environment. Could you please share us what is the challenge for the process of the preparing photorealistic virtual space?
Yeah, definitely. I've been chatting recently to Azad about this as well. And yeah, we did a scene for the UK government, DSTL. We had to go into a lab where they did certain testing for different things. And they wanted a copy of this lab. They wanted a digital twin of this lab. But the lab was very metal and shiny and white and clinical. So we use lasers. That's one of our main problems. If the environment is not messy and rough and easy to photogrammetry, then we got a bit of a problem, because we would bring the laser for that sort of thing, so that we could get the geometry from the laser and more of the texture reference from the photogrammetry, and maybe do that afterwards. The things that are changing for me at the moment, though, we can do a lot of small objects with my phone. Like we're seeing, you know, there's always a level of detail. It depends if you want the final output to be for like a VFX LED wall, or if you want it to be, you know, on the background of an LED wall that's a bit blurred out and you're not going to see it, or if you want it to be held in your hand and looked at really close. I think every bit of that is really important, which is why the system that, as I talked about with the level of detail, that's so important. That's one of our biggest hurdles at the moment for making these models. It is the photogrammetry thinks that the table is 2 million polygons, but the table only needs to be 1,000, for example. And we need some sort of AI that can see the difference between a table and a wall and know that it's flat and change it, rather than having to do that automatically. The automatic retopo stuff, we've seen some things work, but it just doesn't seem to be there. We've got to do it by hand quite a lot of the time.
Thank you very much. Azad, as a result of the development of software and hardware systems in recent years, we can take photogrammetric data with our cell phones and create our own 3D models in 10 minutes. It's like a magic. And when you finish the big project, what is the most important part for photogrammetry, and what is the hardest challenge in the project?
So I think, I mean, I don't know if you want me to specifically focus on like mobile capture, or do you just mean in general with the projects that we're doing that might not involve mobile? I don't know if there's a focus there.
General project.
Right. Definitely the hardest parts, the two biggest hardest parts are the capture and especially if we're doing photogrammetry, ensuring alignment across all the cameras, whether they're terrestrial DSLRs or aerial drones. You know, there's ways of ensuring alignment, but there's also quite a lot of cases, and that requires quite a lot of handwork. With control points and whatnot. And then the second hardest part is the cleanup, like Alex talked about, mesh retopology and texture fixing. And that's something that we really do spend a lot of time with now, especially because for our game, Puzzling Places, like we do need to have extremely consistent texture resolution across the entire puzzle. We can't have one part looking really good and one part looking bad, because then you would have puzzle pieces that are just rubbish. And so, yeah, that's what I was working on right before joining this call. It's what I'm going to be working on after I leave. We've built our own tools for that. It's quite tedious work. I mean, it's certainly enjoyable for me, but it's probably one of the bigger questions that hopefully can be solved through some automated systems in the future. But for the time being, it's quite a lot of handwork, pulling in photos from the data set, cutting them and warping them, projecting them back onto the mesh. You know, photogrammetry can have quite a lot of blending issues, and of course, countless issues with mesh when it comes to certain materials. So yeah, capture and then and fixing are probably the two biggest things. But yeah, mobile is certainly nice. Mobile is suddenly, it means that you can have a very high resolution phone in your pocket. I've done quite a lot of small scale scans with my phone using just the cameras and processing on a PC with a traditional, let's say, reality capture software. There's of course now improvements happening on the LiDAR and mobile processing side. Let it be interesting enough for professionals to use. I think for now it's been a lot of I don't know, a lot of demos, and I haven't really been too interested in that regard. So,
Thank you very much, Stefan. Would you please give information about the different usage areas of your solution in the sector, and how do you help them?
Oh, primarily, of course, in the geospatial sector, we are dealing with photogrammetrists. We deal with companies that do laser and aerial photography acquisition, with UAS acquisition, which is very important, and as of late also we see the advent of hybrid sensor systems. So the combination of very accurate, very dense laser instruments together with cameras, large format airborne cameras. But we also see that also happening in the UAV industry, where we have multiple systems that work simultaneously with one or multiple RGB cameras and with a miniature laser for low flying heights, but high point densities for smaller areas. And as you said before, you know, we also see people now running around with a phone in their pocket that does laser data acquisition. Structure for motion algorithms that the photogrammetrists are very familiar with. They go now also into the consumer world. We're looking at digital twins for entire cities. Those can be updated with up-to-date, sometimes mobile phone information as a layer, showing the differences before a whole city is being reflown. There are numerous ways of contributing in the digital twinning world, even as a standard normal person. You don't have to be a professional. You can use it for pointing out discrepancies, see where the original data sets are outdated. And of course, that's not only a stereoscopic environment, but the stereoscopic environment contributes to the intuitive understanding of spatial relationships. If you look at a flat screen, it's essentially like using only one eye, and nobody wants to run through his daily routines with one eye, and being blind on one eye is a serious handicap, as we all know. And the stereoscopic display really allows us to combine our natural environment with the digital environment. We don't have to shift to a flat screen, to a perspective view. We can maintain the spatial relationship that we are used to and accustomed to from our everyday, and transfer that to the digital domain. I think that's a very important aspect of the future technology, that we look at making head-mounted displays smaller, lighter, even less expensive, although they are not that expensive anymore these days, but they are definitely a little bit too bulky for my understanding. And we move also the stereoscopic viewing technology to the desktop, where it belongs, and also into the city halls with large format systems that allow the audience to understand, the public understand major changes in the cityscape, changing in building developments, understanding of new road networks, how public transportation lines work. You can combine that with real-time data, so there can be feeds into a stereoscopic large format model. There are numerous possibilities and opportunities that take us forward, and I'm really curious to find out what these will be in the next years.
Thank you very much. Alex, the use of photorealistic 3D data is increasing day by day for different sectors, and the sensor size have become smaller, and the 3D data can be obtained even from areas that cannot be entered with system integrated into robots. If we look at it from the point of users, what kind of conveniences do you think these 3D data will bring them for the users?
Yeah, having them on robots and automated.
Yeah.
Yeah, I guess, well, we've got a bit of a partnership with Leica Geosystems, so robots and autonomous scanning is something that I've been involved in recently. They've just launched a couple of new products, which is their BLK to fly and their, so you've got the Boston Dynamics dog that has a BLK on top of it, and you've got a flying laser scanner, which is all interesting. And, you know, I've been pilot since 2014, so I've been flying since Phantom days, and I'm very interested to get my hands on that, but I'm worried about the price. I'm openly worried about the price because there's other drone companies out there that are making drones that don't have lasers on, that can do photogrammetry, that coupled with RTK, you might have a close comparison with the laser data and the photogrammetry data. So I'm very keen to do a test, but it's going to be very good for accessing, you know, areas that are high that need a laser scan. Yeah, that would be good for flying laser, and a dog or a, you know, the robot dog carrying a laser is also interesting. But when you talk about places like a nuclear reactor, where I've spoke to like Sellafield about decommissioning nuclear reactors, and they were coming to us asking, how can we do it? And I'm like, well, put the thing in and then we'll take the laser out. And they're like, no, we can't have anything come out. So I don't know what you're going to do. You'd have to have some sort of wireless communication in some of these areas to make it very valuable, sending a robot in, because you lose it once it goes in, you can't get it out again. So it depends what the environment is.
Thank you.
I'm keen to play with them though, yeah.
Thank you. Azat, when we want to bring the real world into VR platform, why photogrammetry is so important, and also would you please share your observation about the features of VR technology?
Yeah, I think with any sort of 3D system, whether it's VR or even like Stefan was talking about stereoscopic displays, or even light field displays, which I think are sort of the next generation of this technology, it makes sense to have some photography in there with you, because photography is such a big part of our life today in terms of our usage online. Everything we do almost always involves now a text and a photo. And so in VR, you know, of course, 2D photos are not going to go away, but it opens up the opportunity to like suddenly have much more native formats, 3D formats. So whether that's CG objects, which has, you know, 3D graphics have been around for the last couple of decades. But yeah, live action 3D is something that's been very interesting, and not just stereoscopic 3D, but volumetric, let's say. Photogrammetry is one good way of doing it, and it's something that's already working today. It's, you know, you can ship products with it, you can ship even films with it. It's being used today, so that you know, there's no need to sort of have to sell anyone as to like, is this usable or whatnot. It's like, no, it's been in use for cartography, of course, before, and nowadays in more VFX and games. So it's certainly a solution. Another solution would also be light field capture, which involves an array of cameras which would capture a perspective, let's say, and then during the playback, whether that's in a headset or on a light field display, you have all the different perspectives that are captured by the camera array. So that's another option as well, to bring, you know, the real world into VR. Photogrammetry is one way of doing it now because it works. Light field is certainly a few years off still. That's obviously something I'm very interested in as well. But yeah, you have to sort of work with what you can work with today and what you can ship product with today, and photogrammetry is certainly one of those.
Thank you very much. Stefan, what was the biggest challenge you faced in the demands of companies using your products, and how did you solve it?
The biggest challenges for the companies is usually the amount of data that they are producing. So today we're looking at camera systems that take a vertical snapshot with 350 megapixels. You take that times 4, you have a panchromatic, RGB, and infrared. Then you typically deal not with 8-bit data, but with 14 and 16-bit data, so it's twice the volume. And you fly a city and you end up with 5,000 images. You multiply that times 1 or 2 terabyte per image. You have multi-view cameras that not only have a nadir view, but also the 2 oblique views, forward out and backward and out. So you quickly end up with huge amounts of data that you need to process. We do build also workstations, so we are a dedicated hardware supplier also for the photogrammetric industry, for aerial companies, with quite a few customers in this area. And I think this is really the biggest challenge, is not so much the visualization, which is at the very end of the processing chain, but it is about combining the data, triangulating the data, having a consistent accuracy so that you can combine it with other sources, newer sources, older sources. It's the multi-temporal aspect of the data capture which plays a big role. And really, the end product should be nice and comfortable for the end user. And the end user really doesn't want to know about the weeks of processing that sometimes these very large data sets can take. Visualization is the nice end game, so to speak, and you have a wide choice. Once you have a 3D data set, you can put it on a holographic table, which is also coming. Light field cameras and light field monitors are, of course, also interesting technology. But really, that's not the problematic part. That is the nice end product, and this is where the fun starts for the client of this data. He doesn't need to know about all the things that are happening in the machine shop, in the engine room, so to speak. That's the biggest challenge, really, for the companies that produce the data. The massive amount of data that they're dealing with. And we are really talking petabytes these days, especially when you look at multiple products. So you produce a 3D city model with RGB, then you produce another one with RGBI to highlight the vegetation. You produce true orthophotos, you produce normal orthophotos. The number of products that you can generate are enormous, and so are the data volumes.
Thank you very much. We have few minutes, and I want to ask this question for all of you. And what do you think the industries will be affected by this big change? Let's start, Alex.
It's always a broad one. If you're talking about virtual reality and photogrammetry, then I think it could affect everything. So it is really, really broad, because anything that you can do, like we were talking about earlier, when you can view some data spatially or 3D, when you view that data like you would view it in the real world, or hold it like you would in the real world, like imagine the city view you talked about, where you've got a scan above ground and below ground, and now you can hold it in your hand. Like that allows you to, for any industry, to have a different understanding about the data. You could never normally hold a city in your hands, make it bigger and look underneath it. It's going to affect everything for me. There's nothing, we're just trying to take them one at a time because we can't do them all.
Thank you.
Spatial.
Azad?
I don't know. I probably consider 3D reality capture as like a fundamental building block of the metaverse, and in a way that we can't imagine using the internet today without photos. Probably similar with 3D worlds.
Thank you very much. Stefan?
Definitely.
Do you need to repeat my question, or do you
No,
remember?
no, it's fine. Definitely. I think the step forward is democratization of data, both in terms of use and capture. And as we said before, AR is also an important aspect, so that the people with their smartphones, sometimes with tablets, have the information at their fingertips that they need. They point it at an object, they get the information.
Thank you very much. We finished the time. Thank you very much for your participation and this nice conversation and explanations. Have a nice day.
Thank you.
Thank you.